Yeah, look at this.
Oh, James.
Oh, damn. Yeah. All right, so we're going to go through a few questions. Now, sorry? No, this is on the actual exam. Okay, so the neat one we're also going to go through. Just wait for a couple more minutes. Not really, a couple more seconds. So, with the spectroscopy ones, I would say that a lot of you are quite confident with units. But a lot of you aren't at the same time, okay? Things that you cannot do. Number one no-no is put anything but molarity into N equals CV. That C is reserved for moles per litre. I'll tell you why. N equals CV. Yeah? Mole, if we put this in units, moles equals mole per litre times litre. Litres cancel out. Mole equals mole. Very good. It's not mole equals ppm times litres. ppm times litres does not equal mole. Okay, do you get what I'm saying? You cannot do that. You just can't. They will, I actually really think that if you do that in your exam, they're going to look down on the rest of your exam. I actually honestly think that. They're just people, they're humans, they're going to be biased like that. They're going to look at it and say, this person does not know that much about units, and they're going to look at it a little bit worse in your calculations. Just don't do it. Big no-no. Okay, but it's okay, because you have me. We can go through it. So we've got this question. Now, the question is quite complex looking, but it's not actually that complex. Okay, let's have a read of it. When I read chem questions, I cut through all the crap, which I put a lot of crap into your exam because that's what VCAR does as well. If you have a read, mercury poisoning is a disease, so just skim through this, doesn't really matter about that. But it says, okay, commercially traded shellfish is for intended consumption does not exceed 0.5 milligrams of what?
Mercury.
Of mercury per kilogram of what? Shellfish. So of the seafood that we're looking at. Important that you always look at your units and you know what it's talking about. Okay. Now it says one way to determine is through AAS. We know that because we know that mercury is a metal. Yeah? And if mercury is a metal, we'll be using a mercury holocathode lamp because the mercury holocathode lamp, we can excite it, the mercury in there. It will, the electrons will jump up. Then when they emit light, it passes through the sample can absorb this light. Okay, so importantly, draw out your flow chart. Now it starts telling you the numbers, and that's all you should be interested in. It says 0.1373 grams of shellfish tissue. Can I do mass over molar mass, find the moles of shellfish tissue? No, there's plenty of stuff in shellfish tissue. This will only be used for later, for comparison. Okay, so, but this many grams of shellfish is dissolved in 2 mils of acid. What happens when we dissolve something in a particular volume? Concentration decreases. Very good. This is all you have to look at. 4 spec questions, I guess, write this out. 4 spec questions only look for, what am I going to say? Finish me off. Units, very good, but dilution and aliquots. Only look for dilutions and aliquots. That's what they test, your knowledge for aliquots and dilutions. Okay, so here we put it in 2 mils of acid, concentration decreases, mass and moles the same, and this is what we call a dilution. Then it says that It's heated for 3 hours, who cares? But it's transferred to a 500 ml volumetric flask where it's made up to the mark. So all of this is transferred to a 500 ml volumetric flask and it's made up to the mark. So in other words, what's happened to it? Dilution. So that's all you have to think. Dilution, concentration decreases, mass in moles stays the same. Okay? Then it says a volume of 1 ml of this solution is then further diluted to 250 ml. When it says 1 ml of this solution, an aliquot. Very good. So from this 500 ml, we take 1 ml, which is an aliquot. And we all know in an aliquot what happens?
Concentration stays the same.
Concentration stays the same, mass and moles decreases. Jake, are you listening? You look like you're zoning out.
Yeah, no, I'm listening.
Which is scaring me because you don't know this. Yeah? Okay, then it says it's diluted to 250 mils. So I think it just tells you in that statement that it's another dilution. Dilution to 250 mil. Concentration decreases, mass and moles the same. This is very good for you to write out. This doesn't take very long. And the more you do, the quicker it will become. So once you've got this wrapped around in your head, for example, if you work out the mass here, you've already worked out the mass here. Then you can work out the mass here. That's the same as the mass here and here, because dilutions don't change the mass. You've got to make it the least amount of steps as possible. Some people got it right. For example, James, we can talk about him because he's not here. He got it right, positive, but he did like 100 steps, not really, like 10 steps, where you could do 3 steps. And in an exam, you're pushed for time, you just want to get it done quickly. Yes? Was that a question?
Yeah. So the last 2 steps there, the 250 and the 1,
Yep.
they've got the same mass, and then the ones before that have the same mass.
Exactly. These 3 have the same mass. Then, because we took an aliquot here, we have 500th of what's in there, 1/500. And these have the same mass because it's just dilution. Yeah. So I guess you could look at it like that as well. So these 3 have same mass, and these 2 have same mass. Then, I mean, we've diluted it and diluted it, but why have we done that? Why haven't we just chucked it in the machine? Sorry? So that it's in the range of what the machine, like if the machine only goes from 50 to 60 parts per million, and we chuck it in, and it's like 600 parts per million to start off with, it'll just look like the maximum that the machine can handle, right? It'll be saturated. No light will pass through, and we'll actually only think it's here, for example. Okay? We have to also fit it in the calibration graph. That's important so that we don't extrapolate. Happy with that? Okay. So that's why we dilute. So we're not going to dilute and then take this and shove it into a machine. When you read it off the graph, it's always in the final step. Does that make sense? It's always in the final step. Okay, so if you have a look, the question asks, what is the concentration in micrograms per litre of mercury in the 250 ml volumetric flask? So in here, what is the concentration? How can I work that out? Excellent. Tells you the absorbance. Absorbance is proportional to concentration. Doesn't tell us exactly what it is, but that's why we have a calibration graph. And it is, what's the absorbance? 1.03. So we should have got, I've got my actual range. So they accepted between 0.32 and 0.33 and 0.35. I got 0.34 micrograms per litre, as did a lot of you. But I accepted answers like so. Oh, in your exam it looks like this. These all had zeros, because this is a neat question. I accepted, even if you had 0.335, okay? Now, what did we say about how many sig figs your answer should be in? Same as the x-axis. Same as the x-axis, right? So you can't really be too sure of that third decimal place. So you should really round to 0.34. But I gave it to you, but I think VCAT would depend on if it's a hard exam or not. They'd do it like that. If it's a hard exam, they'd be more stringent about the rounding. Easy exam, sorry, they'd be more stringent. Anyway, so it says, that's fine. Part A is so easy to work out. But part B, work out the mass in milligrams of mercury in the shellfish sample. Let's just do that up here. So basically it wants us to work out the mass in here, yeah? If we work out the mass in here, it's also the mass in there. If we work out the mass in here, it's also the mass in there. Do you get what I'm saying? You can cut steps. So it says that we have 0.34 micrograms per litre. Now, that's the concentration of mercury. Okay? Hg solid. Okay. If we had a litre here, we would have 0.34 micrograms. That's what the concentration tells you. But we don't have a litre. What do we have? A quarter of a litre. 250 mils. So you do your ratio, 0.34 micrograms equals 1,000 mils. X micrograms equals 250 mil. Very easy, okay? Then you go, I've got 0.085 micrograms in my 250 mil. Are you happy with that, guys? Everybody's happy with that, yeah? Okay, so in other words, you go back to your thing and you go, I've got 0.085 micrograms. How many micrograms do I have in here? In the aliquot 1 mil? Same. But how many do I have in here?
500.
You do. Now, times it by 500, you guys know with your aliquots that it's just a ratio. If I have that many micrograms in 1 mil, then I have X micrograms in 500 mil. Okay. Now, one thing that I saw some people doing is at this stage, right, they actually did this. They go, oh, I have 0.085 micrograms in the 250 mils. So I have 0.085 micrograms in 250 mils. I have X micrograms in 500 mil. And I only got 2 times the value instead of 500 times the value. Why is that wrong? Because it's diluted. You can only do it if it's an aliquot, not a dilution, right? Because you're dealing with 2 things if it's a dilution. Okay? There's a much larger volume here, which is all water. If all that mass originally came from there, it has to be 500 times that in there. Does that make sense? So once we've worked that out, it's quite a large value, 42.5, but it's in micrograms in our 500 millilitres. Yep. How many micrograms here? The same. And how many in our sample? The same. So, did we answer the question though? No, because has 3 milligrams. So micrograms, it's in your book, 2 milligrams is dividing it by 1,000. So equals 0.0425 milligrams in our 0.1373 gram sample. Does that make sense now? Okay, now VCAR is unlikely to ask you such a difficult question. In the last 7 years, there's been 1 question like that. But you never know, it might come back around. But the good thing is the state goes horribly in it. So badly in it that, like, if you do a few more and you do better, it's going to push you well above the state. So we sort of want something like this. So we want you to be able to answer it. Okay, then the other question is, should this shellfish be traded commercially? What do we need to do for that?
Find out if it's
Where is this
compare values.
Oh yeah, yours didn't print off the last. That's all right.
Because I read that, I was thinking, am I doing something wrong?
Because it's not. No, I don't know where the last page is, but that one's on Dropbox. So, what do I do to see if it's traded commercially?
Is the limit, allowed limit?
Okay, so the limit is 0.5 milligrams, is it?
Microgram. Oh.
Milligrams per kilogram. And we have 0.0425 milligrams per 0.1373 grams. Yeah. So, how can I do a direct comparison? You cannot leave it at that. It's not in the same units, so you can't compare them like that. Take it per, yeah, so 0.0425 milligrams equals 0.1373 grams, X milligrams in 1,000 grams. Yeah? Do you see what I did there? It equals something large. It is 309. 309.4 milligrams per kilogram. Okay, then at this stage you would say no, because you have to have all of your reasoning to gain 3 marks. No, because the recommended limit of 0.5 milligrams per kilogram is a lot lower than the sample limit, than the sample of 309.4 milligrams. No, because the recommended limit is 0.5. If you got an actual value which was less in the previous question than the 0.5, you were given consequential marks. Do you get what I'm saying? But the correct answer is no, because it's higher. Then, what type of lamp would be used? A mercury hollow cathode lamp. Why is a mercury hollow cathode lamp used? One with mercury in it. So, the mercury in the lamp emits light. The mercury in the sample will absorb. Okay? Happy with that? Now, because we've got about 10 minutes or whatever, 15, do you want to go through just one more spec example while this is fresh in your head? Kirili, you can't read everything I've written. I know it's a bit. After a 6 on, I lose blood in my arm, and I can't. It's actually really bad. I'm just like, I actually lose blood in it because I've been writing so much. It comes back though, but my circulation isn't great. What are you trying to just casually dying. Because the recommended limit of 0.5 milligrams is a lot lower than in the sample. Okay. than the example we're going to go through. But the example we're going to go through, NEEP, even made a mistake in their answers. They weren't even able to do it. Pathetic. No, just kidding. Everyone makes mistakes. So, let's grab that question out
I
now.
can't believe they actually made a mistake.
You
Isn't that like
that?
really bad? Like imagine if you were correcting it and then you thought it was right and then you were completely wrong.
That could give you misconceptions. It could.
It's like
That's
the
why
exact answer.
I know. I emailed them and they said, we've sent out the corrected copy to schools. So, but I mean, you know how old this thing is? I mean, how long have people been learning the wrong thing?
2008.
2008. Since 2008, they've been learning the wrong thing.
Is this the one that you gave us that you...
Yeah. Did I give it back to you? So, I should have given back...
gave ours back?
Cheers. Some people didn't get it back, but are you okay?
Yep.
Which bit was the
I can tell your writing now and your voices because I've had to do you. And I've had to say this. I'm like, what is it about writing? I know everything about you. Eleanor? See, why does Jenny put like I don't even call myself.
Yeah, everyone's doing it.
Where did this even come from? And you spelled it with a Z.
I was talking to Carly about this.
I
Apparently,
feel
everyone's
What does that mean?
like dresses, heels, like
It's just so many fails in one go. Alright, Emily Brown. So just flip it to the last page. And Rebecca. And you got yours. Okay. Debbie, you never gave me yours. You showed it to me, but I said you may as well keep it for studying for the exam. Go to the back.
The one about Brazil nuts.
yeah.
It says it up here.
Well, which bit?
No, the whole thing. Alright, so, guys, it says, see, did you get it?
Yes, I think, I did this one too.
Okay. Okay, have a look. It says that Brazil nuts are an important source of the metal selenium. So we're dealing with a metal, so what technique are we going to use? AAS. It says, it's just question 4, the final question. It says a 3.5 gram sample of Brazil nuts was finely chopped and dissolved in 20 mils of acid. Now, acid you take as water pretty much. Acid is mostly water because it's just a solution, and in the end, 99% of solution is water. But it says it's dissolved in 20 mils of acid. What's happened here? Dilution, very good. Dilution, where the concentration decreases, but the mass and the moles are the same. Then it says the mixture was filtered and diluted to 100 mils. When it says it was filtered, guys, you need to know that we've filtered it to remove all of the insoluble residues in nuts, whatever else is in nuts. Then we take the filtrate, which is our 20 mils of acid, along with the mixed in 3.5 gram sample of selenium, like whatever was in there. The selenium is all down the bottom. We filter it to remove all of the insoluble residues. Yeah, Catherine, didn't you get it back? Did you give it to me? Because that last page. Yeah? Alright, I'll have a look for it in a minute. It's not here, so I'll just have a look for it in a minute. Okay, so, and then it was made up to 100 mil. Are you happy with that? Carl? Hello. Okay, it was made up to 100 mils. Yes? So it was another dilution. Happy with that? Concentration decreases, mass and moles the same. Now if you go to your question, it says, why was it necessary to generate the calibration curve? Why was it necessary? Sorry? To determine the mass of selenium or to determine the amount of selenium in your sample. Sorry? Yes, it was. You do think it was. But the answer was, and usually VCAL will phrase it better, so the answer was basically absorbance is directly proportional to concentration, okay? And you need a number of standards to be able to determine the concentration of your unknown based on its own absorbance. Because absorbance does not tell us concentration, we need to be able to use our standards because we know their concentration. So to turn it into a quantitative technique. Now, I'll provide all of the answers to this online, the neat answers, you can have a look yourselves. Okay, calibration curve shows a small amount of absorbance for the one with 0 concentration. I think it's all written on your papers anyway. The answer was contamination. But, no?
What was the question?
The question was that in the 0 absorbance, we do have, in the 0 concentration, we have a bit of absorbance, which indicates contamination of selenium. So if you're using the same glassware to make your blank, okay, but you make it last, which you should never do. You should always go from the least concentrated to the most concentrated. Then we can get contamination and some reading of selenium. Okay, so, yeah.
If I ask that in exam, could you just put contamination could recur? Did you have to explain it further?
Well, 1 mark is just one thing. But if it's 2 marks, you've got to judge by the marks. Yeah? Okay, here, determine the concentration of selenium in the undiluted acid solution. Now, what's that talking about? This, or this? The 20 mils. This was the acid. Where can I get this concentration from? The graph, very good. So, the graph, we need to know its absorbance, and its absorbance is 0.19, yeah, here. So, 0.19 is over here, and
Oh, that's cool.
2.6. 2.6 ppm is in the 100 mil. So, 2.6 ppm in 100 millilitres. How many ppm is in the 20 mil? Less or more? Is it going to be less or more concentrated? More concentrated by how much? 5 times as much. 100 over 20. Okay, so in other words, your C1 V1 equals C2 V2, or just knowing that it's going to be more concentrated by a factor of 100 over 20. That's the one I always use. So 2.6 times 100 over 20 equals 13 ppm. Okay? That's the easy part. The hard part, you guys are all good at dilutions now, which is good. But the hard part is this one. Calculate the mass in milligrams present in the sample of Brazil nuts. Okay. Now, 13 ppm, what does that mean? 13 grams in 1,000,000 grams. Now, that's saying that if our sample was 1,000,000 grams big, we would have 13 grams, okay?
Can't you make it milligrams first, just because it asks milligrams?
No, I'll do that after. So, 13 grams in 1,000,000 grams, okay? How many grams do we have? No. Okay, think about it. This is the part that you have to understand because this will separate you from the state. Ready? 13 ppm is the concentration where? In the 20 mils. Is it the concentration in the 3.5 grams? No. So you cannot use a ratio with the 3.5 grams.
Wait, why not? Can't you do X grams in 3.5 grams?
Because, okay, just think about it. 13 grams, 13 ppm is in here. Yes? Not in here. This concentration might be 50 ppm. If we knew the concentration in here, because we've diluted it. Do you get what I'm saying? If we knew the concentration in here, we could go 50 grams equals a million grams, X grams equals 3.5 grams. But we don't know the concentration in here. It's like what we did before. We only know the concentration in here. So you have to work out the grams first, and because the grams stay the same with the dilution, it'll be equal to that one there. Okay, this is what's going to separate you. So 13 grams equals a million grams, X grams equals 20 mils. 20 mils equals 20 grams.
Wait, why is it equal grams?
Because 21 mil equals 1 gram.
I thought that was only for water.
Yeah, but an acid is mostly water. You assume the density of water. I've asked. You can do that. You have to do that. Because if you put 3.5 grams here, okay, let's do both scenarios. First, let's do this scenario. I think it was 0.006 or something.
It's 0.0046.
Okay, 20 times. Oh, 0.0 triple O?
4 O's. If you do it with 3.5.
No. Oh, okay. So 20 over a million times 13 equals 0.12326 grams times 1,000 equals 0.26, right?
Yeah.
Equals 0.26 milligrams. Now, if we do it Amy's way, and that is 13 grams equals a million grams, X grams equals 3.5 grams, what did you say you got?
I got 0.4046 grams.
And then equals 0.046 milligrams. We get a value which is less, yeah, than what we expect. But that's because we have a volume which is greater than 3.5 grams. This concentration only refers to in the 20 mils. It doesn't refer to in the 3.5 grams. We would have to actually work out the concentration in the 3.5 grams to use that ratio, which we don't know what it is, because you can't assume 1 gram equals 1 mil for, what was the sample? Brazil nuts. You can't assume 1 gram equals a mil for Brazil nuts. Yes?
So wait, is the 0.26 milligrams, is that in the 20 mils? Or is that in the 3.5 grams?
That's in the 20 mils, which is in the 3.5 grams. Because it was only a dilution. Okay, let's see. Neat. I'll show you what I mean. Sunji Dutt, this is it. Alright. Okay. If you want to read it. So, hi, I gave my students a NEET on spectroscopy. There was a ppm question to determine the percentage by mass of selenium in Brazil nuts. A 3.5 gram sample was dissolved in blah, 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 blah. In the NEET work solutions, they determined the mass to be 13 ppm. To be 0.046 milligrams. I don't think that this is correct, as the concentration of 13 ppm is in the 20 ml acid solution, and therefore would be a higher concentration in the nut sample. However, the question doesn't tell us that if it's a dilute acid, and therefore not sure if 1 gram equals 1 mil, like with water. I worked it out to be 0.26 milligrams. Is this correct? Hi Lorena, thanks for your email. You are correct. There are some errors in the chemistry test titled spectroscopy and chromatography. The errors have been reported, blah, 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 and soon new test. Do you believe me?
Yeah.
Do I have to prove myself like that too? No, but are you happy with that? It's because the concentration that we worked out through that timesing by 5 business is in the 20 mils, which is a diluted version of the 3.5 grams, because we've added a water. So if we've added an acid, which is mostly water, so if we've increased the volume, we've decreased
Is
concentration.
that just that mole thing we were talking about, like using it as C? Even you can't, like, I don't get it. Like, I get it, but is that the mole thing you were talking about at the start? Like, moles equals moles, but moles doesn't equal something?
Moles equals moles, but
When
moles.
you're doing...
Oh no, that was like
What was that?
that was M equals CV. I was saying that to use N equals CV, the units of moles have to be in mole, the units of concentration have to be in mole per litre,
Yeah.
and the units of volume have to be in litres, because they cancel out and they give us mole. Yeah, that's a bit different. But do you get that? That 13 ppm, but it's easy once you figure it out, because you can just work out the mass in here, and because it's just a dilution, you've just added other stuff, it's the same as the mass in there. Are you happy with that? Another thing we could have done, just very briefly, and then we'll finish. Another thing we could have done is taken our concentration of selenium in the 100 mils. What was it? 2.6, was it? Was it 2.6 in the 100 mil? 2.6 ppm?
Yeah.
Okay, it was 2.6 ppm in the 100 mil. I could go like this, 2.6 grams in 1,000,000 grams, X grams in 100 mil. Yeah? Work that out, it works out to be 0.00026 grams in here, which is also in here, which is also in here. But one thing you can't do is 2.6 grams in 10 to the power 6 grams, X grams in 20 mil. Why can't you do that? Because it's not the concentration there. It's the concentration there. You've got to be careful. You can only use the ratio with the volume that the concentration is in. So write that in. Only use volume where conc is in. I don't know. Just tattoo it to your foreheads. Anyway, are you good now? You just have to do 10 more of those questions and you should be sweet.